I was advised that when you are late for something, when you arrive, you do not say sorry for being late. Instead, you say thank you for waiting. Wish to start the program for the day, and just to help us to understand the order for the day, so that we get everything in place, we will be having an opening prayer. After the opening prayer, we will do the national anthem and the East African anthem. Immediately after that, we will have a short video playing, and then we'll go into the presentations for the day. To get us started, I wish to ask Kevin to make his way close here. Kevin, please, wherever you are. Kelvin? Kevin? Kevin will be giving us the opening prayer, and immediately after that, we will have our DJs helping us to go through the national anthem, and then we can play a video of the project, and immediately after that we'll begin calling on the stage the presenters for today. I can see they are ready, they are set, they are loaded, they have lots of content for you, and I'm sure you are going to appreciate that you are here today. Thank you so much. Kevin, please come on board.
Good morning, everyone. Let's bow down for word of prayer. Oh dear Lord, we come before your presence this morning, thanking for the gift of life, oh dear Lord, for the gift of presence, oh dear Lord. As we start this session, oh dear Lord, be with us, and whatever will be shared with us, may you have the knowledge, the ability to retain it and use it where applicable. In Jesus' name I do pray this, trusting and believing. Amen.
Thank you so much, Kevin. Thank you. God bless you. May we now arise for the national anthem.
Afrika Mashariki, tuwezeshe kuishi kwa amani, tutimize na malengo yetu. Jumuiya yetu sote tuilinde, tuajibike, tuimarike. Umoja wetu ni nguzo yetu, idumu jumuiya yetu.
We may take our seats. Thank you so much. Did you know Mombasa Port Area Road Development Project is the first in construction road contract by Kenya National Highways Authority? There have been a few others, but not to that magnitude. And that's the reason why we've come here to listen to the experts, people who have participated in that project. I must tell you, there is a chance that some of you see time without seeing another project of that nature. And I'm just a special opportunity to get a chance to listen into the story of this. Perhaps started more than a decade ago. Now it's coming to conclusion. There is a product on the ground. You can always get a chance to go and inspect and see it physically, and see the size, see the marvels, and get to experience it firsthand. But before, for those who have never gone there, you have a chance to listen from the people who have been on the project right from the start up to today. We are glad to have this project and to have the people who have the knowledge on the project to speak to us and take us through the journey and teach us the lessons that they've learned, which by transfer we are also able to learn at the end of the session today. Shortly we are going to have a clip on one of the packages playing in a few minutes, and then we'll get set so that we'll now be calling our speakers for today to help us understand what they have for us and to take us through the journey of the Mombasa Port Area Road Development Project. We can play the clip now.
department. That's what MANPAD means for those who might not have known. And one thing you also saw, we have one of the longest bridge in East Africa, which is about 1.4 kilometers, but Mwete will tell us. So we'll get to know what they did, because they were actually piling in the sea. I went there when we were doing it. It was quite interesting. In fact, that is a video we should also show next time, when how you are doing it, or maybe you'll do it when you are talking. I wish to urge all our participants to actively engage in today's discussions, to share your insight. Let us harness the collective intelligence and creativity of our workforce to drive continuous improvement and position the authority as a leader in sustainable road construction. I also wish to encourage each one of us to actually participate in this forum and to make your regular contribution in what I mentioned, our knowledge hub. So when you get anything that you think we could share, put it there. Then we have an innovation portal where we are inviting all of us to share their innovation, and soon we'll be able to be rewarding the best innovation. In conclusion, let us embrace the knowledge sharing as our baby, to feed, nourish, for it's ours all. It does not belong to PRC. Knowledge sharing is for all of us. And that's why we have been going to each and every directorate. First we had HPD, then we came to PRC, and now we are in development. So we want to make these forums as inclusive as possible. So thank you for all that. Thank you so much for your attention. Now I think I'll return the mic to the MC to invite the other people. Asanteni sana.
Director, before you go, please declare the meeting open.
I wish to declare this forum open. Asanteni sana tena.
Thank you so much. Now all the righteousness has been fulfilled. Thank you, Director. Thank you. And when Director mentioned about Engineer Mutea and the depth of learning that he has done all through the years, I remember that Engineer Mutea was my classmate. Isn't it something to be proud of? And it's not just being a classmate. He was my classmate in a class of 13 people. And when we did exams, only 2 people passed, him and me, in that class. I think I should be writing it in my CV. I was in the same class with a veteran. Thank you so much. Fact number 3, this project has the biggest structures of bridges in this country. Big in terms of the quantities of materials consumed, big in terms of the materials used both below the surface, under the ocean, and above the ocean, and also big in the sense of the length of the structures. Again, we'll be getting these details from the presenters, and it's quite amazing, something worth listening into and being part of. As we said, we have been challenged by one of the veterans that learning does not stop, and we are here to continue doing exactly that. It's now my pleasure to invite Engineer Dorcas Sinde to come over and begin us on the journey for the content for this session today. Engineer Dorcas is one of our young engineers in Kenya National Highways Authority. On this project, I want to call her the Gen Z expert on the project, and she'll introduce us to the journey of the project and help us understand where it has come from before we call the other veterans on board to come and take us through their presentation. Karibu sana, engineer.
Good morning, everyone. My name is Dorcas Sinde. I am an engineer, and I work with the JICA team, the team that handles JICA-funded projects in the special projects department with the Directorate of Development. So in the spirit of embracing new technologies, as our Director Gatitu has just spoken about, today I would like to talk to you on the topic of application of AI technologies in bridge maintenance. And so this presentation has been divided into 4 sections, as you can see on this slide. And it will take approximately 15 minutes or so. So I would like to start with my introduction. And so in the recent past, especially in the last 15 years or so, since the inception of the authority, we have seen a very large increase in the number of bridges constructed, and even an increase in the number of bridges that are planned to be constructed. For example, the upcoming Mombasa Gate Bridge. So on my next slide, we can see more bridges, and many bridges were constructed to supplement the already existing but aged bridges that were constructed pre and post-independence. Now, we have to acknowledge the fact that bridges are very critical pieces of infrastructure in our road networks, and once they deteriorate, it's very expensive to replace them. So for this reason, it is important for us as civil engineers to be very keen on our maintenance processes. Now I'd like to provide a brief background so that you can be able to understand the nature of our problem. So, maintenance needs for the authority have been constantly increasing because of the increase in the road networks and increase in the road assets. As you can see on the graph on this particular slide of budget allocation against financial year, the budget allocation has been fluctuating, but with a general downward trend. So what does this mean for us? It means that the money that we have cannot be able to cater for our maintenance needs. It then prompts us to think of innovative ways that are cost-effective, while at the same time efficient in managing our bridges. Let's have a look at bridge management. Traditionally, bridge management systems were characterized by being, 1, visual and manual. Bridge management processes traditionally relied heavily on visual observations and manual processes such as destructive tests and non-destructive tests. For example, acoustical tests like the hammer or the chain drag, or other tests such as magnetic particle testing for identifying fatigue cracks in steel bridges. It was also characterized by being reactive, where we would only take action when there's extreme deterioration or total collapse or sectional collapse of a bridge. Again, it was characterized by being standardized, where all types of bridges would be subjected to the same kind of maintenance treatments, regardless of the type of bridge. So, this resulted to various limitations, such as delayed detection of damages, or high costs. Again, we also have the lack of safety to bridge inspectors, and also the process could be subjective because the kind of inspection results from one bridge inspector to another would be different with human errors. So as engineers, all over the world now, engineers are thinking and asking themselves, how can we make our bridge management systems be predictive rather than reactive? How can we ensure that the results are not subjective? How can we ensure less costs, and how can we ensure safety to our inspectors. So this leads me to this next slide, which is on the integration of artificial intelligence on bridge management processes. So what is artificial intelligence? Artificial intelligence is the simulation of human intelligence processes by machines. As illustrated in this slide, the process of artificial intelligence begins with data collection. We have to collect data, and this data has to be of high quality. Then we prepare our data and move on to our next step, which is the creation of an AI model. So, the creation of the AI model, this will depend on what you require. What do you want your AI model to perform? So we have several building blocks like machine learning, neural networks, computer vision, natural language processing, and robotics. You can use one or a combination of these building blocks to create your AI model. We then train our AI model based on the data that we collected. And after this, we validate our model and integrate it into a prediction system. So now, what are the benefits of integrating AI in our bridge management system? What are we aiming at? We are aiming at having a bridge management process that can allow us to do early detection, improve safety, have accurate analysis, and enhanced decision making. On to our next slide. I would like to now discuss about various ways of integrating AI into our bridge management processes, and I will start with this one, intelligent detection. As you can see on this slide, today we have several equipment that are used in the bridge inspection processes. For example, drones, high-resolution cameras, and even 3D scanners. So these equipment are now integrated with AI tools, for example, machine learning and computer vision. This equipment provides us with data such as photos and videos, which we can then input into our system. As you can see on this slide, the system can be able to generate for us 3D models, either from point clouds or finite element analysis models. The system can as well be able to detect defects on the surface of the bridge and monitor its growth over time, and even map it on the 3D models. And this can be very efficient in allowing us to do our monitoring processes. So I'll discuss two examples for intelligent detection. In this example, we have crack detection with AI analysis. We have high-resolution cameras or drones taking photos of a section of a bridge that we're particularly interested in. And then, with the AI detection system, we are able to map the cracks on the surface of interest. For example, this example, the AI detection system used is called Kumono's AI, and it is a system developed by Kumono in a corporation in Japan. It has a detection rate of 99%, and the accuracy is constantly updated through AI learning. So this is important for us because instead of going to site and randomly checking where are the cracks or manually searching for the cracks, the system already tells you that this is where you need to go and look at. The second example is again this instrument from the same company, Kumono's Corporation. So, it's a surveying instrument that has a built-in concentric crack gauge, and it can be used to obtain the crack lengths, the widths, and the position data. So these two examples fall under intelligent detection. Next, I will discuss digital twins. So next, I will do a discussion on digital twins. So what is a digital twin? In our context, a digital twin refers to a virtual representation or a virtual model of our bridge structure. For example, let's say we have this particular bridge, we have this particular target bridge. Then we use a 3D scanner that is placed at different setup locations around the bridge. We are able to obtain data from this 3D scanner in the form of point clouds. We can then use this point cloud data to generate a 3D mesh that is representative of the surface of the bridge, as you can see in this particular photo. The 3D model can then be integrated with AI such that the sensors are installed on this particular target bridge, and they continually, in real time, feed the 3D model so that the 3D model is able to mimic the behavior of the bridge. Currently, there's even studies to see if we can be able to undertake virtual inspection using virtual simulators. In this second example, we again have an actual bridge. And from this actual bridge, we create a finite element model. We can create such models from softwares such as Abacus. For example, this particular model was created using Abacus software. It is representative of a digital twin for this particular bridge. We are able to simulate deterioration at the particular area of interest. For example, in this photo, deterioration for corrosion was simulated as vertical thinning of the stiffener and the webs. The condition of the support was simulated as either pinning the support to represent healthy bridge condition or fixing the support to represent unhealthy bridge condition. So from this particular simulation, we're able to get results in various forms. And these results can be used to train our AI model. So through building blocks such as machine learning and neural networks to enable us to undertake predictive maintenance. So for predictive maintenance, we are able to assess how defects impact the capacity of the bridge over time, and AI algorithms will be able to calculate the remaining useful life of the bridge. Finally, we can be able to undertake accurate retrofitting and repair methods. AI does not come without challenges, and here I've outlined a few of them. For example, the high initial costs. The quality of output also highly depends on the quality of your inputs. We also have loss of human expertise because of over-reliance on AI, and we also have the risk of loss of jobs. But notwithstanding, the conclusion of this research is that AI has the potential to significantly enhance bridge management processes, and it is recommended that the authority should conduct in-depth research on emerging AI technologies that are relevant to bridge management, and secondly, to implement AI solutions within the current bridge maintenance frameworks. So these are the references that were used for this research, and this marks the end of my presentation. Thank you.
Thank you, Dorcas. Thank you so much for that great presentation. When I was calling her, I had suspected that she's going to come and speak about technology, AI, BMS, robotics, intelligent systems, and machine learning, and she did not disappoint. Asante sana. Let's give a round of applause. You can have your seat. Thank you so much. That was deep stuff on bridge management and bridge maintenance. Asante sana. Now we shall be moving to the next presenter. But before he comes on board, I want to give us fact number 4. Okay, we are ready for fact number 4. We are still looking at the fact file. The project is one of the big projects in the recent past to be financed between the JICA, the Japanese Development Corporation, in partnership with the Kenyan government. And the discussion started around 2010. And today is about 14 years down the line. We have the product on the ground. Thank you so much. Engineer Ogege coming now on board. Engineer Ogege is, in this presentation we had one youthful presenter and 2 veterans. Engineer Ogege is a second veteran. He has been here for many years. There is something that I got to know about Engineer Ogege. He is the first class material. Wale, those ones who are in Juja, Jomo Kenyatta University, there is something we used to call Babaroa for the top student in class. Now Engineer Ogege is in that class, the A student, the Babaroa student, and the top of his class. And he has been a veteran. He has worked with the government for many years. He's a career public servant, but also a professional engineer, a consultant to that matter, and a person with depth of knowledge on matters engineering and roads infrastructure building. He is also the deputy director and the person at the backstopping office in charge of the MPAD project as we speak now. Karibu sana, director, and now take us through the next session of presentation. Welcome.
Thank you, Engineer Howard, and good morning, ladies and gentlemen. As Engineer Howard has said, I am extremely old model, so I don't know whether I will be able to catch up with the artificial intelligence, but we are trying our best. Just a little recap. MPAD, actually the preparatory works didn't start in 2010. I was a provincial works officer in Coast between 2005 and 2007. And those are the days that we used to go for site visits. We would wriggle our way. It was very difficult to go to site between 2005 and 2007. We would wriggle our way across Jomvu, getting to where the SGR station is currently, somewhere. There is a landmark called the explosive jetty, just as you get into the beginning of package 2 at Mwache Bridge. That was the farthest that we could go. And then we would stand there and tell the people that it will be crossing here, that creek, then cross over the peninsula and cross the other creek. But we want to thank God that we have lived to see it become a reality. And that is the beauty and the pleasure of engineering. So we can now move to the presentation. I'm old school, so I don't know whether who is putting the presentation on. So as they get the presentation ready, we have come a very long way. Remember from that 2005, now it's 2020, 24. So a whole 2 decades for the actualization. And in one of the slides that Dorcas did show, there is Mombasa Gate Bridge, whose preparatory works actually started in 1978. 1978, just about the time the construction and preparations for Nyali Bridge were starting. That is the time we conceptualized the Mombasa Gate Bridge. And Mombasa Gate Bridge, we are just starting the actual works now. So now into the presentation, I will talk about the use of IT in managing slopes. This is a caption of MPAD Package 1. Look at the construction, look at the splendor, look at that slope. And these slopes require attention. If they are not attended, they are susceptible to failure. So my presentation is on the actual experience on MPAD Package 1. Package 1 was completed, and 2 years after completion, we had a massive failure of the slope at kilometer 6 of that construction. And so we have been using drones to carry out inspection of propagation of slope failure, and then see how we can use that knowledge to mitigate, prevent failures. So just imagine this, we came from this beautiful thing, and then 2 years down the line, we had that massive failure. We lost the entire Mombasa bound carriageway. This is the carriageway to Nairobi coming from the port gate. So the whole of this area failed. The SGR line is somewhere down here. It was almost also being impacted by this failure. The airport is over here. As a result of this failure, you see this is an airport patrol road. The whole of this airport patrol road was lost. And then just a little over here, the failure extended, and we lost about 6 meters of the secondary runway of Mombasa Airport. So you can imagine 3 critical infrastructures: airport, our roads, and SGR, impacted by that slope failure. That is the reason why it is critical to continuously monitor, study slopes, and ensure that we keep them stable. And so, just like Engineer Dorcas said, these little gadgets, the Gen Zs enjoy using them for capturing parties, weddings, and parties. But now these gadgets are becoming extremely useful. This is a drone, and drones are increasingly becoming the norm. Helps us to collect that data fairly quickly and reduce downtime, and of course we access those areas a lot more safely. Now, as you have seen, we had a massive failure on that MPAD package 1. The whole construction of MPAD package 1 cost us about 11 billion, and the slope failure cost us another 1 billion to repair. Within a period of 2 years of the completion of the project. So then that makes it extremely necessary to constantly be monitoring these slopes so that we don't incur those huge costs to repair the failures. So we use the drones to observe the slopes and its hinterland, and we do this after every rainy season. Then we compare the slides. We did the rainy seasons for Mombasa are February, March, April, and then the current season that we are going into is the long rainy season. So we did one inspection during the first rainy season in February, March. We have just finished the second inspection. And from these inspections, we have realized development of some very interesting things called sinkholes. And these sinkholes are extending all the way into the premises of the Kenya Airport Authority, beyond our right of way. We use this data we collect to ascertain the cause of the damage. It also helps us look at the soil characteristics and the flow pattern of the water. And then with that, we can accurately propose necessary actions to be taken. And so this is a very useful tool for evaluation as it saves on time. Now, that is a map of the area of package 1. This is our road. That is the airport. So package 1 runs from Miritini up to the port gate. This is the area where we had the massive failure. And so we constantly are monitoring these areas to ensure that we don't encounter that failure again. You can see this is the runway, and in the course of that first failure, we lost part of this runway. Very expensive to reinstate. And now this is what the drone is able to give you. This is protection works. You can see protection works that we did on the slope. And constantly, there are certain things developing here that are called sinkholes. These sinkholes are not easy to detect in good time by eye. And so the drones help us to detect the approximate areas where there are sinkholes. And then we can also monitor the state of the slope, whether the slope protection is still holding or it is in imminent danger arising from these slope failures. From what we did in February, you can see something here, and then you can see something here, you can see something there. Those things that are circled, those are sinkholes. And these sinkholes pass water vertically, then eventually the water gets its way laterally. Finally, it pushes our slope protection and results into that slope failure. You can see this. That is a sinkhole that we're able to detect using a drone. From our slope protection, like here, we built a drain. These drains are also now, because of the sinkholes and the water and soil flows, they are getting slowly clogged and not serving optimally. Now this sinkhole, after they have been identified, you can now then use survey equipment to give you the exact location of that sinkhole. Then we are able to walk there. Then you can pick a lot more details of the sinkhole. Now what you see here, look at it. That is the sinkhole. And this sinkhole is inside the KA premises, but its impact comes to our road. You can see how deep it is. That is a human being right inside. And so if this is not quickly attended to, then you know what it means in the next few months. when we did the first study in February, this was a sinkhole. When we did it in June, look at that, and look at that. So the sinkholes are progressing pretty fast, which is a signal to alert us that we need to take action quickly. Again, look at that sinkhole, and the sinkhole is already impacting on our slope protection here. So there's the danger of losing the whole of this slope pretty soon. Now, after identifying these things in February and now in June, we are able to estimate the size and also start detecting the manner in which the landslide is going to propagate. So with this, we can see that the whole of this and the whole of that is already a potential slide. Another sinkhole developing at kilometer 7. So after we capture the data, we can now physically go to site and pick a lot more details of the sinkholes. And then this is the pattern that the failure is going to take. So with the drone and the survey equipment, we can get the actual coordinates, and then we are able to now send inspectors and get a lot more details about the sinkholes that are being propagated. Now, this is the estimated area. Already sending high alert. Comparison still So look at this area. This is not our area. This is a airport perimeter fence. Some of these sinkholes are not, they are not in our road reserve, but their impact will come to our road reserve. So flying a drone over that area helps us to identify them. Then we can collaborate with the Kenya Airports Authority, collaborate with the Kenya Railways, so that jointly we plan preventive measures. Now this one is already beginning to impact on our slope. And in the next few days, if nothing is done, we shall lose this slope again. So, again, a lot more sinkholes. You can see them after we have identified with drones, located them. Then we now walk in there and pick more details. Look at this now. This is our slope. The water is already, the water from the sinkhole goes down underground, splashes over our slope, because the drain here is already clogged and already impacting our road. Now, after that inspection, we are able to do comparison between the data that we pick and the geological information of that area. This area, the soil here at the time of inspection of design, we can link what we have picked now and the information that we had at the time of design. Then, using that, we can now accurately design countermeasures to stop these failures. So, we are already preparing for huge failures here, huge failures there. You can see the airport patrol roads, already a huge crack there. Look at the sinkholes. So we are sitting on a time bomb. So that is the area that we are monitoring. This is already the damage that is occurring from the water that is coming from the sinkholes. The water seeps vertically, it forces its way laterally. You can see our slope protection is already giving way. Now the history of this area is that other than these sinkholes, there is an area that has water accumulation and springs. And even in dry season, we have this kind of flows out of those springs into our road, about 20 liters per minute. So we need to plan how to capture that and safely take it into the natural drainage system. Now, with the drone we can see gullies and sinkholes. Look at the depth of some of these sinkholes. Started as very humble things in February, gradually growing. This is the damage already occasioned up to now. As an immediate intervention, we are proposing that we unclog the drainage, desil the area, remove some vegetation, but we need to start planning now for proper subsurface drains to protect this slope. So, as I've said, we do this operation jointly with the Kenya Airports Authority, because that is a protected area. You can't even fly a drone without permission from Kenya Airports Authority. We share this knowledge with the Kenya Airports Authority. Actually, as we talk now, they have already used the data that we have given them to source for money to start the maintenance of the area, their areas, so that they don't have another failure, another collapse of the runway. So, drone inspection has several benefits quite similar to what Engineer Dorcas has shared. We get clear pictures. We get to cover huge areas. We detect these things called early. We can accurately estimate their sizes, the pattern of soil erosion and water flow, and then quickly see how to start mitigating before the slope finally caves in. Visual inspection is cumbersome, although for final details, we still have to send people to get details into the sinkholes. But now they don't need to walk the whole area. They will be going to a specific place that has been identified using the drone. These reports we are doing jointly with Nishi, who is an expert from Manishin Expressway. And we are finding this extremely a useful tool that will help us, not only in this area. Once upon a time, when I was still, I think we were in Eastern Province with Engineer Gatitu, there was an area called Mutonga. Mutonga, there was a very huge landslide on the road from Embu to Meru. And the funny thing with landslides, you know the times that they happen. When you are enjoying your sleep most, they normally happen around 2, 3 a.m. The one that we had on Mayu Road the other day, it happened at what time? It was 4, 5 a.m. And so you can imagine, least prepared, but the damage is massive. So this is a tool that we encourage, that we embrace as an authority and use it so that in all our roads, particularly the ones with high slopes, we can constantly monitor these slopes and mitigate in good time. Thank you.
Thank you, Director. Another round of applause for Director Ogege. I agree with him that landslides happen only at bad times. The one in MPAD started at 4 p.m. on Sunday. So the problem with the slide starting at 4 p.m., the alert was given at around 3:34 p.m. on Sunday. On that day, even if you wanted a small barrier to help you create direction, all the drivers at construction sites are at home, sites are closed, the keys to the vehicles are kept somewhere, which is also locked with another key that is kept by another person. So the reaction time to get anything back up, it will take you, I don't know, until 9 p.m. in the night. That's when we had the first response of an equipment that could be able to help any issue. And yes, landslides have that habit. And arresting them in time will be a very good thing to do. Fact number 5. This project is one of the projects that embraced a lot of technology. I was in school and we were taught things that used to look like rocket science. And you know the way lecturers teach in school, sometimes they sing the lesson instead of explaining the lesson. So we were taught pre-stressed concrete technology, post-tensioning and pre-tensioning. The first time I ever interacted with this kind of technologies was on this project. Interestingly, the spans that were required on the bridges, but not just the spans, the number of girders that were required to be produced on this project were so many. I don't know, they were in the hundreds. The production line was quite something else. And those are very interesting topics to learn on this project. I also realized that when you run your topographic survey and you get on the edge of the ocean, it ceases being relevant. Because beyond that edge, it's not even called topography, it's called bathymetry. So there was some new vocabulary to learn. And the equipment you use must change. The theodolites and the dumpy levels don't work under the ocean. Yet before you design and before you build, you must get to know the ground profile under the water. Some of it might be as deep as 15 meters, 20 meters. And if you do not know it, you can't design it. And if you can't design it, you can't have it. Ladies and gentlemen, now join me in welcoming Engineer Motea Gidinji, the consultant and the lead consultant on this project, who is going to share with us lessons learned on Mombasa Port Area Road Development Project. Please let's give him a round of applause as he comes on stage to take us through the next and final session of the presentation before we go into question and answer. Karibu sana.
Good morning, everyone. Yes, Director Atitu, the entire Kenyan fraternity, the other visitors from Kura, I understand. It's my pleasure to be with you today just to share a few things about MPAN projects. Just like my other colleagues have mentioned, this project, Dongokudu project, we can put on the shrine, was conceptualized many years back. In fact, people call it Dongokudu because of the location where it was located initially. You know, these days, if somebody puts there, I'll show you the map, was passing through a place called Dongokudu. Is slightly east of the present day where Mutesa lands. Now, these days, Mutesa lands at Mwangara, but before it was crossing over to a place Dongokudu. And those are many years back. Yes, they are many years back when this project was conceptualized, but there were many challenges. One, mainly funding, and there are various co-financiers who came in to support the projects. The last one was, before JICA came in, was World Bank. They did a bit of design, And finally, we had JICA coming in the year 2011 because we were doing the proposals there 2012. Then we started the designs, detailed designs 2013. So today I want to take you briefly through the project. I'll give you a brief of the 3 packages, then the lessons learned and the recommendations. One of the things why we are maybe picking on these lessons learned, I want to emphasize that, is a number of things, failures we have encountered. I realized we had encountered some of those challenges before, but since they were not documented, we also repeated the same mistakes. So it's good for these projects when they come in that we document the challenges, how we were able to overcome the challenges, the lessons learned, we document them so that the future generations can refer to that information. I'm trying to put this on. The next slide is not moving. Oh, sorry, I don't know. This one still going on. Oh, yes. Okay. Thank you. Yes, our project was in 3 packages, or routes if you want to call them. The first one starts here at Miritini. That is about 22 kilometers from town center there to this. This is the road which was formerly called A109, now I think is A8. And from here, it takes a southern direction. This ends here where the engineer Okeke was showing those high slopes here, where package 2 starts. SGR is somewhere here. When we started this project here, SGR was not here. SGR moved to this area later. Initially, I think SGR was supposed to come that direction. But around the same time when we were doing the construction, they came here, and so we had to give way somewhere. And then from here, it moves around this place here where Engineer Okeke has dealt everyone, where there were slope failures around the airport. And then it ends at the new container terminal at Kepevu. We also put 1.3 kilometer inside the airport, such that people coming from south can easily enter the airport, not necessarily going through that direction. We had 3 interchanges. You had an interchange here. This other one in Mwache. Here at Kipevu, what we had intended to do before, we had to change now to give way to some space to SGR. I have said that here, SGR initially was intended to come this way, but they changed here. And this area is very tight. Those ones who have been to Mombasa recently now allowed that area. You see the problem of navigating through the last one. It's solved, but since we were fighting over space, this entire area before was part of the sea. And so we had to give space. Engineer Okeke has given the challenges of this area, but generally around this area in West Mainland, there is material called shale. It's not a common material. In fact, in other books, they call it mudstone. It's very hard in the natural state if you have not disturbed it. But if it gets into contact with water, it becomes mud very fast. To excavate through, you almost require jackhammers. But on contact with water, quickly it turns to stone. I said that it's good to document the challenges and lessons learned. Now I'm being prompted through this talk to reveal in 1981, where this, you see this land where it comes through here, around this area, I don't know if many people know, there was a landslide around that area. Because this material is shale, and the same failure we were been encountering in a number of places here, I realized this is what we had, and I had some documents stuck somewhere, which we had encountered similar problem, but since nothing happened, we assumed the whole place now is stable. The same time around Kipev here, there was again some landslides. If you go to walk through the port here, you see the slope protections, the way they have done it. Of course, everybody has been trying to do his own thing, but if we have been documenting the challenges, we did not need to repeat some of these problems. Around the airport here, when we were doing the designs, we had encountered the sinkholes Engineer Ogege is talking about, but after looking at it casually, we assumed they are stable. The ground is stable now. We don't need to do anything else. And that casualness, being that casual, you can see the danger that came later. We had noted that there were sinkholes here, but see, one of the problems, what happened is around 2019, 2020, airport was doing some renovations inside the airport. The moment they disturbed the equilibrium, because it is just a dynamic one, water, they broke, even them, they don't know exactly what they did. They broke some waterways there, and the water now came this way, and there was failure. This is why we had a problem here, and there was another landslide there, and even here, this is now where Engineer Okeke was saying it broke. Okay, that is now package 1 and those challenges. Package 2 starts from here, crosses with the first bridge here, 660 meters, Moache. And then through here, we have got, initially at the design stage, we wanted to do an embankment this way, because from the video shoot, the one we were showing you, you saw that this area is marshy. At the time of high tide, water comes up to that place. But because we wanted to cut costs, instead of having one continuous bridge from here to that place, what we did is we had a bridge there and an embankment in between. And then at Moache, we have got now another bridge of 690. This area of embankment now, to treat us, I'll be talking about it later. It's one has to be very careful about that one, because you are putting or constructing an embankment in the sea. So from here we have got U-turn Bay at Sunsa. Our road comes through the long bridge, 1,440 Moache here, Muteza, then crosses over. This was the second package, and the third package was from right at the end there, through this place up to Kebudan. This area is the proposed special economic zone, which is starting now. Okay? Generally, that is where our MPAD, that is what we call MPAD projects. I'm trying to move the next slide. Is it the same? Can somebody help me? The slide is not moved. Oh, it's moved. Okay, yes, sorry. Now, I have quickly said the 3 packages, what they are, or you can call out one. The first one is 11 or so kilometers which I have shown, and then the other one, package 2, about 9 kilometers. Package 3 is 6.8 and 1 kilometer along the A7 road, which makes it a total of 7.8 kilometers. Okay? Okay, now I want to quickly give you a brief of each of those projects, those 3 roads. Yes, package 1, what the works that we were doing there, the normal site clearance, drainage works, subgrade of 300. Our GCS, we end 350 millimeter, quite thick. DBM 175, AC 150. 50. The reason why this pavement on this side is heavy, it is the one which carries all the road right from the port. And you know, most of the people hauling material from the port, they fear damages, so they try to clear their cargo with trucks that are not weighed. So that's why we had to put a heavier pavement than the other. Also, we have put a way bridge, but it's way in motion at kilometer 1 from the start place. And we had put CCTV cameras around the airport shelter area, but they were vandalized. When we had put street lighting, but the street lighting, because it was conventional, other people came and vandalized the system. And now, during the dark period, people vandalized the CCTV and the other installation. Major structures in package 1 was at Miritini, the first interchange. We have a U-turn bay at kilometer 1 where you have to enter the way bridge. And then the way bridge station just ahead there. And then Mwache interchange. We have a Mukupe jetty. This, there is a structure there. It's a bridge. But we have not decided to carry very heavy road, so we restrict because mostly it is to use to the fire and praise and the fishermen going to Mukupe. Then at kilometer 4, we wanted to put a U-turn bay, but the moment we introduced SGR, we realized in future then people may tend to come and clog the main carriageway. So we added another box culvert to make it look like a roundabout on top, such that people don't have to stop along our main carriageway. Then there is airport interchange, and then the airport access. We also put a railway bridge. We moved or reconstructed about 1.4 kilometers of the existing meter gauge. That is at the beginning. We have a long bridge about 110 at Ago, what we call Ago. Ago is the gas place. And then we have got the airport shelter. That's the airport shelter. People thought it's just, they don't know the reason why we had to put that. KCA demanded, unless we have a shelter of this nature, this road cannot be located at this place because it's quite close to the airport runway. So that's why we had to put this shelter. It's a kilometer long. And the middle part, which is 100 meters, we had to put a box type, like a box culvert, thick, such that even if somebody was to come with a bomb, we can't easily blow a plane that is landing. Oh, sorry. This is almost where Engineer Ogege was showing those other slopes. This is at Mwache interchange. From here, our road, if somebody is coming from Nairobi, you want to go southern bypass, you turn through behind Yapa, you go behind somewhere below there, you come out there, okay? And if you are coming from South Coast, you can join the main highway here. So the slopes Engineer Ogege was showing is not only one side, it was all sides. This area is, again, very difficult. It was rugged terrain, and we had to position our interchange from here. One of the key things about this project, the package one, the contractor was China Civil, and in cooperation with another railway, number 11. But the consultant, we being one of them, we were a group of 6 consultants. The contractor seemingly is there 2, but the consultants are 6. And I've listed them there. Kataira, Oriento, Anshing, I've missed out Anshing is. Then Noken, BAC, Uniconsult. 6 of them. We started in May 2015, a contract of 3 years, and we finished dead on time. 3 years exactly. We finished on 17th of May 2018. Our contract amount was approximately 11.5 billion equivalent in Kenya shillings. We concluded at 11.45 with about only 24 million shillings above. And that's due to other reasons. One of the things, maybe that's the reason why people wanted us to talk about this, is how we have managed to, first of all, finish on time within contract. Because it's most contracts these days, it's a very difficult to do that. Our VOP, we had provided, hoped to, in the contract there was provision of 10%, but ours, we finished about 6%. Well, at that time when we were doing construction, between 2015 and 2018, at one time we were even recovering money from the contractor, from the VOP. That from the indices, instead of us paying the contractor, we were deducting from the contractor. And they wanted to say that is possible. So by the time we finished, the prices went up. So overall, we only paid 6% from the VOP. That's why we are able to do the project within that cost. There were a number of other things, variations we did. Some of them was like the pedestrian footbridge near the weighbridge, the SGR, and at Kipevu, we put another interchange. One of the other things we spent a lot of money on is, although the area around kilometer 6 failed, we had done quite a bit of work, but we are not completed. We were thinking that what we have done was good enough, because we were trying to protect the road, but we were not protecting ourselves right from the source of the problem at the airport. So we had spent quite a bit of time, money, particularly from our other savings, from VOP and others, but what we had done was not good enough, and it cost us an additional 700 million, which we were funded from JICA through package 3. Yeah, that is package 1. I can go to package 2. Yes, package 2. The mean works are about 9 kilometers of dual carriageway. This one has no much of interchange, it's only one U-turn bay. But it has, in terms of earthworks, we have got very difficult material because we are putting embankments in the sea. This is now the package that we were working right in the sea. At least the others were just circumventing down to the sea area through the shores. But package 2 is why we are going through the sea now. And that's why we have got, we had to come up with a way of treating the swamps. Then the pavement is slightly reduced because GCS is 175, DBM 150, AC remains 50. Then we have a U-turn bay at Sunsa. Then here we have got 3 bridges. The first one 660 meters. It has 21 spans. 3 of the spans are 40 meters, but the others are 30 meters. And you can imagine each girder has got 10 girders. That's why Owen was saying the number of girders we have produced are many, 21 spans. Then in Sunsa Viaduct, we are is 690 meters, 46 spans, but here because we are calling this one a viaduct because it's like a low bridge, they are more spans here because it's not for navigation, so our spans were shorter, 15 meters. So that's why we have 46 spans. Mutesa is 1,440 meters. We have 47 spans. Again, 3 spans are 40 meters. The others are 30 meters. After learning the challenges of the slopes in package 1, we improved a bit in package 2. You trace that and change. What we had intended to do in package 2 in the slope protection, we changed a bit. And then also CSR, we have gravelled that 8 kilometers from Susa to Marcellus. We have also constructed 2 police stations, one at Mwache, the other one at Sunsa. Yes, this is Sunsa Viaduct. You can see our pedestrian walkway. We are not using normal steel guardrails. We are using concrete. That means they are less prone to vandalism. So right now we are changing to anything that we think could be susceptible to vandalism. We are changing to other alternative means. Like here now we have, instead of using aluminium guardrails, we are using concrete parapets. Okay? And then for our concrete barrier, in order to move fast, we were using slip form, a continuous pouring. You set yours still, and this, sorry. Sorry. Yes. This equipment is continuously pouring concrete as you move it. For us to move at some fair speed. Okay. Now this is Mwache Bridge, where we started package 2. When we pray the creep later, you see how the place used to look like before and now how it is right now. This was the firearm jetty that the military used to evacuate their military hardware. I said earlier that this area is marshy, is part of the sea. We would have preferred to put a bridge across here. Instead, we have put 660 and another bridge 690. But in between here, we are using embankment. And this is the long bridge, Mutesa Bridge, viewing from package 3 direction. Those are the spans. And you can see the spacing of the spans here is 30 meters. And the central one there, to allow for bigger navigation, we put 40 meters. Few things about the project also. It was tendered in 2017, but the award of contract was in 2019, and we commenced the project in March 2020. We gave the contractor order to commence. A week later, there was lockdowns because of COVID-19. And so we suffered a lot of other challenges. But all in all, even with that, we have been able to attain substantial completion within almost the time we said we were supposed to finish on 13th March or 12th March 2024, but we were given an extension of 123 days, which is basically 4 months and over. The project equivalent was 24 billion, 24.2. To date, we are 22.6. There is that balance there. We have not finished everything, but we are almost within the contract sum. If we exceed, it will be by a few cents. Variation of price in this contract, this side, because now we are in the period whereby prices have escalated too fast, is where we are at 18%. I said the other one was 6. This one is 18. I think still comparing to other projects, our project's VOP has been the lowest. Maybe that one somebody has to confirm. That's an allegation from me. Package 3, I said the area is 7.8 kilometers. The main features is Kibudan interchange. We have 2 U-turn bays. We have several box culverts. There is a protection works, huge earthworks. Reason for huge earthworks is in a bypass, we don't want people entering our road from every corner. So we lifted the embankment such that it is not easy to access, because this is a bypass. Because everybody who wants to come to develop has to join our road through designated places, not everywhere. And this is the pavement structure. The pavement structure is 125 GCS, 125 dBm, and 50. It's the same continuation of package 2, but during the negotiation, the financier was not very convinced. We even needed a dual carriageway this side. He thought we should have a single carriageway. So it took a lot of negotiation to agree to fund dual carriageway in package 3. But ourselves, as Kenyans, we know the challenge we have here in the Mombasa Eastern Bypass. You put a road single carriageway, within a short time, it requires to be put as dual carriageway. Few features, you can see our slope protection. This is a U-turn bay at Mwangara. We have improved on the slope protections. Some of these places we thought we would plant grass, but the moment we note the sign of shale, we were changing. But we were changing when we were already on site. This is at Kebundani interchange. By the time you come to Kebundani interchange, the soils here are good because you are on coral. Okay? The problem with our road is the soils keeps on changing within a very short distances. Few highlights of this project, it was also tendered in 2017, but we started in 2019. And it was to be 24 months. Within the first 24 months, we had finished, but because of land acquisition, we could not finish Kebundani interchange. And so that's why we have been on site from that time. The contract price was 4.7, but now where we have reached is 4.9. So there is an overrun of 157 million, which is about 3.3%. The VOPs are around 14.5%. I am putting this because of a comparison with the other projects, because a number of other projects in the later stage, the VOPs have tended to be even sometimes going to as much as over 50%. So we want to see maybe the lessons learned from ours, so that you don't have to make the same mistake we also made. And if I was to do the same road, what I would have done probably differently. One of the things is when you come to the site, you are given contract for supervision. Design review is very necessary. Even if it's done by a very experienced person, please go through it. Don't go through it casually. I know sometimes people have tended to look at the consultant who has done this work. You think he's very experienced, and so you yourself, you casually look at the project, the documents, and you start. It's necessary to do design review. Even if somebody else has done the design review, do yours, because you may discover a number of things. I have not come up with any contract to date that is perfect. There is always something, because you see, these contract documents are done by many people. Somebody somewhere may add one or two things that may not be very suitable, or you may start seeing other problems. Because we did design review, but I don't think we were that thorough. There are a number of things we could have changed at that stage before even construction. So the design review, look at the documents, look at the BOQ. If there are areas that it is not adequate quantities provided, get to know that early and prepare what measures you have to do about that. 2, the program of works. Contractor gives a program of works, and that program of works looks detailed, but then the supervision team sometimes don't look at it in detail. This program of works is a very important tool, particularly when it comes to claims rate. So if the contractor points out that he can do a certain work within, say, 6 months, you have not picked it, and maybe because of his other challenges, he does not do it in 6 months, he can start blaming it on you, or blaming it on the client. But from the very beginning, his equipment was not capable of doing it in 6 months. Okay? So it's necessary to an experienced person to look at the program, look at the equipment the contractor is doing, and see how reasonable they are, and even the sequence of things. 2, when it comes to things like land acquisition, it is not done. You can influence the contractor to take a certain path, particularly if you have not acquired the entire corridor. So you give him, you influence him to change, so that he can start with the areas that you have paid for, giving you room to deal with the rest. Okay? So it's important, these two, at the very preliminary stage, somebody to look at them carefully. Now, as I said again, the staffing, one of our challenges, the number of 6 consultants coming from all corners of the world. And then you are the team leader, you want to get them to do the same thing. People have different experiences. People have different backgrounds. But one of the things they know, first and foremost, they have to do things Kenya way or Kura way if it's a Kura project. So those people don't assume anybody knows. And also it's good to prepare everybody such that you harness the strength of everybody. Because here the tendency sometimes is people think that one of our key problems in the beginning was expatriates thought they knew it all. But without fighting, without pushing or using force, you get everybody to know and to respect what everybody knows, including the young engineers. I like them contributing in our project, because no matter how young you are, you have something you may see that I have not seen. What you have seen is sometimes not a factor of age. It could be how keen you are. So it's good that that number of staffing come up with a way of getting everybody to work together. And one of our ways we had to do was to have regular meetings, weekly, bi-weekly, monthly, and individuals meet with individuals and get to know what are their challenges, what they think about this solution, get to discuss and have everybody contribute. Our other problem was contractor, which was good, is subcontracting. In our documents, we normally say maximum subcontracting should be 40%. My take is that I don't think that thing is necessary. We used to put that to avoid briefcase contractors, but I think it's being overtaken by events. Most contractors, like the Chinese, sorry to say, to be that particular, when you see a Chinese contractor around, it's not one, very rarely is one company. It's a multiple contractors within there. There is one who is doing caravans, there is one who is for bridges, there is another one for whatever else. But there is a management group on top that seamlessly is able to put all these people together. Like our package 2 contractor, I don't think he has, the equipment he has is very, very few. Most of his work is management. He brings somebody for piling, he brings somebody for earthworks, he brings somebody else for whatever activity we are doing. All of them, he puts them together. I know that there is that provision, but when I looked at it in the contract, I didn't want to tell him you are infringing on the contract. Because I knew if I go that route, unless the contract is repudiated, it's cancelled, he came prepared to do exactly that. Manage other contractors. And since he was efficient in doing so, we concluded that we want the road, let's not go to other politics of how he is. So there is that problem of that limitation of subcontracting. I think naturally in Kenya, we need to revisit that and see how we can promote our own to be doing that. It's very well implemented in building works. Anybody you walk around building works, whoever is called main contractor is doing very little. He brings a plumber, he brings people for plastering, different groups at different times. But he manages that. It's the old system is very expensive, and it makes it very difficult for our local contractors to enter the race. Yeah. Then together with that, people can specialize in whatever they do. They are able to bring the expertise in specialization. And when we are doing the construction works, please, even the design, engineers, particularly structural, try to standardize your design. It doesn't make a lot of sense. You have caravat, one of them 5.5 meter wide. Then the next place you are having 6 meter wide caravat, box caravat. Contractor will be forced to do different formworks. If you are to standardize, I know the quantity of material may increase, but it is efficient and the contractors will tender much lower. So here, because of the standardization of the girders, 40 meters, the one for Sunsa were 15 meters, they could be produced in a factory setting, and we were able to move fast. And the girders could be produced even when it is raining. You are not limited because it is a factory setting. So there is a lot of advantages in standardizing elements in structures. And because this is one of the areas where we were going to take a lot of time during construction, particularly in the bridges. So by sheer method of standardizing the girders, that process was finished slightly ahead of time. Even the effect, particularly package 2, the effect of COVID-19 was able to be absorbed by how fast we were able to move with the construction of the bridges. The other thing, in major projects, it's not good to have the locals become bystanders, watch the game from far. It's good, particularly from the client point of view, to see our ways and means of involving the local community. In our project, we involved what we call community-based organization in planting trees, and they did a good job, mangroves like that. You see, if you go to the normal requirements of procurement, of course, they are not properly registered, so they cannot participate. But if you have some PC items that the locals can participate, that will be very good, because then they own the project, and there's a number of challenges you as the supervising consultant have with the locals, because they are feeling they are benefiting somehow. It's not much even, but whatever that little, it makes a lot of difference to them. Then they own the project. Then other challenges you have, like even land acquisition, they are able to see it, because they can see this project, like the coast people, they say, it's benefiting them. So since they can benefit monetarily, it's not this project for those Chinese or those Japanese. They feel ownership. That is, helps a lot. In the matters of land acquisition, we have found a lot of challenges because of ownership, but we were able to overcome by picking the areas that are less expensive, and then direct our the little money we were getting from there. And where the areas, particularly where there are litigations or other challenges, we would talk to those people. NRC and given us early entry on most of the project places, but you see, if somebody is living in a certain place and yes, that is his house, unless he's paid, he is not going to move. So it's necessary for you as a consultant to get involved with issues of RAP. And you have a very good, this area in the past we have been taking it casually or leaving it to NRC, but it can store the project. Unless you have learned, you are not going to move forward. Ours, we deployed people until to the NRC offices, because unless you do so, NRC does not have enough personnel. And the issues to do with the land are complicated. Sometimes Ghana has provided money, NRC has released the money, but the PAP cannot receive the money, because you can imagine some of those people, they opened their bank accounts in 2015, hoping to get money that time. The account has been running zero. All of a sudden, somebody wants to deposit 4 million there. Of course, the bank will not agree. So some of those things, we and personally to intervene and get them moving, talk to the bank manager, go with even with the DC to make sure that this process is completed. If we had left RAP issues or land acquisition issues to either Kenya or to NLC, it would have been very difficult. But we formed a very good network from Kenya, NLC, and ourselves, and that's why we have been able to reach that far. In future, if one of my recommendations is if you have money lying out somewhere, and instead of staying there when there is needed elsewhere, you can direct NLC to pay what is payable. Because I think 2 years ago, Kenya had given NLC money, they were not using it, Treasury saw it, then they picked it, but yet we have so many unpaid PAPs. Even the project, I have talked about the project, the affected persons need to be assisted for them to move. Otherwise, if you say you are an engineer and you keep a roof, you are not going to get the land to give to the contractor. Second, number 10 here, of the specification and the conditions of contract. One of the things about our design, we also are borrowing from the other specifications. We largely relied on our Kenya specifications, but there are few areas, like now you see we are working in marine environment, that we needed to borrow from others. As an engineer, you should not be shy from borrowing where you are deficient. So like our steel piles, the epoxy to apply for the steel piles in the sea, all those, the standards we are using were from Japan. Bearings, we also use this. I know we use restomatic bearings for normal bridges, but in this environment in the sea, we had to use a different, it's still port bearings, but we use the Japanese standard because of they last longer and they are more durable. And our bridge, since it's not on a straight, it's curved, we thought they would do better with the higher standard. When we will start the construction, insist on the contractor producing his shop drawings or construction drawings. That way, when the contractor is producing his drawings, he gets to understand, until he has done it. But you see, the problem sometimes is you tell the contractor to produce shop drawings, he takes the engineer's drawings, changes the title block, and he returns to you. That's not the essence. Let him produce his own shop drawings. That way he gets to understand what are the challenges. Because then he prompts you. He comes to the engineer because he realizes the way you put one of those things may not work. And it helps you see the weaknesses in your design. Because he is the person finally who is going to do the construction. So it's necessary the contractor produces his shop drawings. From there, our monitoring and evaluation, you have to be very close, because you have to check every piece of element of component of work to ensure that you are on time. Because what is critical path today may be different tomorrow. Initially, we thought in our project, our critical path was bridges. But bridges, we finished all the bridges by January this year. But before we realize, something else which was not critical path as cropped in now is the critical path. So when you are doing the supervision, you have to do monitoring of each one of them and how they impact the entire project. And you have regular meetings with the contractor to discuss all those aspects. Again earlier, that when we started our project, a week later, COVID-19 broke. All our staff, half of the staff, because half of them were foreigners, they left. But we had done a contingency mission. And I told our local staff, please, wherever you are, you will be the one in charge. Your counterpart, if he leaves or he decides. For 9 months, they came and they were shocked. They met that everything was moving seamlessly. That's the first time even they had a lot of respect with the local engineers. That means we can do it, but we also sometimes some of these things is good to augment your knowledge with the foreigners. Okay? They do different things differently. Finally, I came to conclude that they know some few things that I don't know, and I may be knowing some things that they don't know. So if we can put a teamwork, we can produce a better result. But in COVID-19 issues, one of the things and to tell our staff is to keep good records. Because when a pandemic of this nature takes place, contractor is, of course, some few works can't continue. Later on, he wants to put a claim as he has done. So how do you analyze? It's necessary, and you don't know exactly what type of claim you'll make. So it's good to have proper records of the performance of the activities, what is lacking, if the challenge the contractor is getting is in terms of important material, and from there, how is it impacting the project? So it was necessary to keep that. And we saw now our effect of COVID-19 is what we awarded in only 123 days, but not affecting the entire project. Okay? But you know, COVID-19 was lasted for how many years? Almost 2 years. But so at least the effect is smaller. Other things you have to observe, particularly in our case, was health and safety. 14, 15 there. When we started, when we were working, we had about almost 30 marine vessels. From rafts to barges to ferries. We had a ferry of our own. And we have, instead of the RIS vehicles, we had RIS boats. So, because we are working in the marine environment, we had a total of I think 3 marine vessels in all of them. But when we started, there was one of the rafts there. I think we were casual people. Some of these Kenyans also take things rightly, but we had a fatal accident. 2 people died. They were not even Kenyans. It happened in the evening. And from there, we were very cautious. So anytime you would come to our project, even now, before you come, we must induct you in terms of safety. But from there on, our project has won twice the best safe projects in the country. I don't know who was awarding that, but I was told we have been awarded. Yes. Can you move this? I think it's serious. Oh, yes, sir. Yes, now quickly on the works. I was saying it's good to review the projects, the documents. In one of our documents, one of the mistakes was in the bush clearing. Instead of putting bush clearing as in terms of hectares, that one was put, but somebody had gone further and put there counting the number of trees, and he confused the diameter of a tree with the girth. The girth, is circumference. So if somebody assumes the girth as a diameter, the number of quantities was going to be very high. And so we had to get around that problem because the contractor was going to do bush clearing and claim about 400 million. Then treatment of the settlement areas. I began, because of the failures we have witnessed, the rock fill If you go to our specification, you see it talks of stones of 300 size, 300 millimeter, like diameter. But if you are going to go in this type of swamp areas and you put 300, they sink and disappear. So you have to come up with a different design for your swamps. In fact, you have to come with very huge rocks to key in there first. And our swamp, after rock fill, we have to build the embankment to some level, and extra weight, which you keep on now monitoring for some time before you put your pavement. In package 1, we did not treat Agor Bridge properly. Howard, if you go there, you find a drift there, like a bump. Because from the bridge, we had about 15 meters of fill on the swamp area. But the way we treated it was not very good. And so now there has been settlement over the years. Right now it has stabilized. But at that time, when we put the pavement, it means it was still undergoing settlement. So in package 2, particularly, we had to make sure that whatever now, before we put the pavement, we have reached the end of the settlement. Okay? Then the subgrade, we had problems of this material. In some other places, we had to improve by taking the normal material and then adding some other soils to get the required slope. I said again, the slopes, we have to be very careful with the shale material. The material sites, our material sites, when it came to like package 2, we had a lot of problem getting the correct materials, but still we wanted very high quality, particularly for subgrade. So we had to be very careful with the material for DBM. One of the things I want to maybe encourage you engineers, when it comes to AC or DBM, the hardstone, try to use stones that are known, or the material sources that are known to produce good quality. If you go to start using new quarries, sometimes like in coast area, we have a lot of disappointments. And as far as possible, use the locally available material. You don't have to go from far. But like in Mombasa area, you cannot get good stone for surface dressing. So people come all the way to Nairobi to get good quality. Particularly class 1. Yes, which we are looking for. IPCs, just I'm finishing. IPCs, we have not had a lot of success in this area because of payment. And as a result, we have been punished heavily. In package 1, interest on drain payment alone is 600 million. Package 2 is reaching 550. So we need to do something. One of the things, I know there is cash flow problem, but in projects of this nature, like ours, the approval time of IPCs is 56 days. So any delay in the process contributes that 56 days from the time you receive the RIE. Not when it is approved by Kenya. Is when the certificate is handed to the RIE, days start counting 56 days. And so you can see we have been punished heavily because of that. So because of payment, we engaged the financial, JICA. First of all, that the retention, because it was 80% to be paid by JICA and 20% by Kenya government, we agreed the retention will go to Kenya, so that Kenya can only be paying 10% for the time being, and JICA agreed to be paying 80%. But over time, even that 10% was not forthcoming, so we negotiated with the JICA to pay for us, and the Kenyan government has many pockets we can pay at the end. So that's what we are doing right now. variations of price. I gave quickly our package 1, package 2, package 3. You see where we have, what have we done mostly? It is from the formula and the contract overrun. You can see package 1 is 0.1. Package 2, it will be about 1% maximum. And the package 3 is 3.3. You know, it's very important from this formula, and I gave this talk here before, when you are having your variation of price, if you are doing design freeze, this factor here called A is very important. This means what you don't want to be affected by the variation. A number of people have been putting 0.1. The other talk I gave the other time, I showed everybody why it cannot be 0.1. In my assessment, it should not be any time less than 35%, 0.35. It should be higher than that. It's the element that you don't want the contractor to benefit from variation of price, which includes his profit, his investment, all those things that you should not be, you want to compensate the contractor for variation in price of fuels, lubricants, steel, not for his own investment. So people have been making a mistake. They put this factor O. That means this other factor B, C, D become high. But by making this high, these factors become lower. 2, some contractors have seen what is likely to happen. If it is fuel, over the last 2 years, if it is this one is for fuel, somebody checks and finds most likely in the next 2 years, steel will increase or fuel increase. And he puts a bigger factor in that one. So, the conditions of contract do allow you to check later. Particularly if you find that they are being unimbalanced. Then you can call the contractor and tell him, no, we have to revise these factors. Because in some projects, you find somebody has shown fuel is 30%. That can't be. Or steel is about 40%. If the steel doubles, then you can see why quickly your contract doubles. So those factors, I said, normally people have not been revisiting them during the tender evaluation, but somebody has to be looking at them constantly. Because if the variation can account for 40%, it means you, at the tender stage, you never looked at the 40% of the element of the contract. So it's necessary to look at that. Finally here, knowledge transfer I've said is very important for all of us. Let's to document lessons learned during the project and even after the project. In our project, we have had several workshops where we have invited people from Kenya and other places to come, and we have taken them through the process of what we have done. We are trying to document now everything. And training was part of our task, which we wanted to make. I don't know how many of you here have benefited from that. We have trained, including, the last one was on BIV equipment for bridge maintenance. And we had several calls coming in to be trained on bridge management and maintenance. So it's necessary to all through to document and to transfer the knowledge so acquired. Engineer Gatito said, if you are lucky, you are not likely to find another project of this nature. You can see the last one was Nyari Bridge, which was finished in 1980. Now it has taken us 44 years to get us to the next. So it's necessary to document this, and I said this before. Some of those things we encountered some 40 years ago, we thought it's over, seems to have come back to haunt us, but they caught us unaware. It's necessary. Some of these places you go as an engineer, you meet the type of challenge you are meeting, somebody else had met similar one before. It was only that it was not documented. But if proper documentation, we can easily transfer the knowledge. Finally, I'm putting a conclusion, need for a review of the document study. Program of works, you look at it. This issue of 40% have something ought against it, if it can be removed to promote our contractors. Standardization of elements in structures, necessary. Please engage also the local community, see how the local community can blend in the project. CBOs, there are some few things they can do. Land acquisition should not only be left to Ken and NLC. The supervision team should take an active role over it. Different standards can be used to argument what Kenyans have, but you must know what you are doing. An engineer must always know what he is doing. Issues of the claims monitoring, you have to do that from day one. Don't wait for the claims to come. Put everything in proper perspective. Use the locally available material as far as possible. It is helpful, it's cheaper. And IPCs, I would, here is more of Kenya, please note you also, you affect the process. I always say IPCs, if you see a mistake, some of them mistakes which are not fatal, you can always even get them corrected in the next subsequent one, if they are not major, instead of holding the certificate. With good management, we can maintain contract cost overruns. Because this is very important for an organization like Kenya. You have your budgets, overruns, they stretch your budgets. So good management can help. And one of the ways to do is, in the recent past, is to check on the variation of price. Knowledge transfer is very key, and the supervision staff should work harmoniously. Everybody can contribute, and including the project engineers from Kenya. When they come to the project, materials people have been coming, they have been contributing, and we have a very wonderful team from Kenya, from materials department, and all of us, we are proud of what we have been able to do. Thank you, Maureen. Thank you, Dorcas. Even Owen was there, down there one time. Yes. And Engineer Ogege in absentia. And all those people who have contributed. We are trying to put, I have other details of how we were doing the other projects, but that one is not for this session. If you want, we can share that, how we were doing the Uganda constructions and all those details. Today was just to give you an overview of our projects and how we managed it. If there is something to learn from it, thank you very much.
Thank you so much, Engineer Mutea. Thank you. And another round of applause for Engineer Mutea. Thank you so much. Now we are coming to the tail end of today's presentations. Basically, we've finished with the presentations and we are going into question and answer. I'll be requesting Kelvin, he was somewhere, he'll be helping me to move around the microphone. If we have any questions from anybody from the plenary, please feel free to raise your hand and ask it now. As I look around for those hands, I can see Maxwell's hand is already up. I'll be giving you the fact file number 6. Fact number 6 about this project. It is the first project ever that when I looked at bill number 1, it had the resident engineer's boat over and above the resident engineer's car. And for the first about 6 to 8 months of the project, the boat was actually being used more than the car. Because you could not access anywhere on the project with a car except the boat and on your foot. Engineer Maxwell, you will go first and ask your question. I'll take about 3 questions before I come back to take the responses. For housekeeping issues, Engineer Ogege, due to unavoidable circumstances, had to leave early to attend to a matter. So we'll be having 2 of our presenters taking those questions. So when I come from Maxwell, I'll be going to, I think it's Mary. Okay? Yes. Thank you.
Okay, thank you. Thank you so much for organizing this forum. And much regards also to the presenters. Well done. Mine is two. One is on the standards to Engineer Mateo. On the standards where we had departures or where we had gaps in our standards and manuals. You have highlighted just in a nutshell, but I think it would do good, especially to us in design and in during construction, to probably have a detailed analysis highlighting areas that were identified maybe lacking and which standards were adopted for those areas in different components of the project. Maybe and just analysis of the gaps and what was a standard adopted for that particular component or manual or reference that was made. The second one is on the barrier, the median barrier separating the two carriageways. We saw that it was cast in situ. I'm wondering what was the details for the anchorage, and considering the fact that that the barrier should also not only prevent a vehicle moving from one carriageway shifting to the other, but also provide a refuge in case of a crash, so that the severity is not very high. That has been the preference why we have had preference for steel, because it has some fractional properties that allows bouncing back of the vehicle during crash. So in this case, if the barriers were cast in situ, does it mean they are 100% rigid? And that's why I'm asking about the anchorage and even the length. Would they allow any movement in case of a crash? Thank you.
Thank you so much, Engineer. We can take the microphone to the lady right at the back. Please say your name and proceed with the question.
Thank you very much. My name is Afemi Sauke. My question is, actually, what are some of the challenges? This one goes to Engineer Dorcas. What are some of the challenges we encounter while integrating AI, and why are we not using it yet?
Thank you so much. Thank you so much, Femi. Before you move far away from there, I think you have two hands. You can give the microphone to the two gentlemen.
My question is to Engineer Mutea. What kind of hydrological studies did you do for the bridges? Because usually when you're constructing bridges along the river, usually take catchment area and all that. And number two, for the subcontracting, what would be the effect of eliminating the briefcase contractor and having those individual contractors doing different works supervised by the consultant? Thank you.
Thank you. You didn't say your name, Eric?
Muridi.
Okay, thank you. You can move to the gentleman, and then we'll take a question from the lady, because we have two gentlemen, before we come back to the answers.
Yeah, thank you. My name is Tony. My question is to the first presenter, Engineer Dorcas. So in the event that the application of AI in bridge maintenance is fully adopted, will it require any kind of training to the engineers that will be undertaking the maintenance? And if so, how accessible will this training be? Thank you.
Thank you so much, Tony. And now we can have a microphone to the lady seated down here. Please tell us your name and proceed with your question.
Hello, my name is Alexis Wesula. I am a terminal intern. I can't seem to get a real job. Okay. I have 3 questions. First of all, the sinkholes, how are they treated? I realize the engineer is not here. I hope someone will take the question anyway.
Yes.
And regarding the sinkholes, I think Engineer Dorcas can answer this. Whether the detection is done using machine learning from the data that you get from the drones, or you just manually check the pictures. And if so, do you need special training? Okay. And then those are 2. My third question is for the consultant. Considering the monitoring of those sinkholes and their treatment and constantly having to do post-project work, can you still justify your cost and benefit for this project in 10 years, 20 years? Will it still be worth it? And then, I'm done.
Thank you, Alexis. I was thinking you'll go up to question 6, but thank you so much. So we will take the responses before we come back, take another round of questions. And I'll ask Dorcas to go first to respond to the questions which were fielded both to her and perhaps the ones that were fielded to Engineer Ogege, and then we'll come to Engineer Mutea. Thank you.
So I'll start with the first question, which was, what are the challenges and why are we yet to adopt AI? So I think some of the challenges that exist include, for example, the perception and attitude of people towards adoption of AI. And secondly, the costs involved, because adoption of AI systems involve high initial costs. And lastly, in the case of our organization, I think one of the challenges might be that we are too focused on construction and maintenance and our other activities, but we tend to forget the research aspect. On to the next question. In the event that AI is fully adopted, will it require training, and where can we access this kind of trainings? Yes, if we are to adopt AI, we will need to train ourselves on the creation of AI models. We have to learn as I had mentioned earlier in my presentation, things like machine learning, computer vision, natural language processing, and robotics, so that we can be able to come up with creation of these models. And we also have to learn things like Python. Luckily, these things are now online, and we can easily register for courses and be able to learn. The next question was, how are the sinkholes identified? Is the drone equipped with some sort of machine learning that is able to identify the sinkholes automatically? That's how I got the question. For this question, I may need to forward it to Engineer Mutea for him to answer it. Thank you.
Thank you so much, Engineer Mutea. You can take the questions directed to you.
Yes. Maybe I can start with the last one, where Dorcas is trying to answer regarding the sinkholes. The drone does not do the subsoil detection, so it's only visible. The drones were used because it's a security area to avoid people going there with other survey equipment. So that's the reason why the drones were used. Otherwise, it's necessary to visit those areas after seeing the image from the drone. You go there, try to find exactly where the sinkholes are visually. Those sinkholes, some of them, the airport, from the way it was constructed for the first time I think in the year that is there. What happened is the area was rugged. And because it was rugged, they tried to even where there were hills and valleys without necessarily compacting the material. And so some of those areas, what happens is the soils and the material beneath there, parts like silica, they are still undergoing chemical weathering. So when the chemical weathering occurs, it creates a void beneath there, particularly because of water. And when they create the void, then water passes through there. Because there were the valleys, the water starts following those channels. It's not very easy for the drone to discover that. Maybe one using the old topo map he can try to find out where those bodies were. But currently what they are doing is use the drone to see the surface, deformation, and then you can visit those areas to try to identify the sinkholes physically. Let me go now back to the other questions which was to do with the standards. There are a number of things where our standard specification, which was done in 1986, falls short of. Things like piring, things like steel piring is not there. There are a number of things that there are shortcomings. We are in the process of making new manuals. We'll try to see how much we can try to contribute to our manuals that are under preparation. But the old manuals and a number of shortcomings that the way we used to do things that time now, including the vehicle loadings, if we are thinking in terms of the axle loads, the type of number of axles we used to have in 1986 and now they are different. Now you're having big trucks with 6 axles. The configuration. So we need a new design to take care of all those changes in the expected number of the axles. If you go to our design manual part 3, you realize the traffic we are talking about is up to T1. These days we are talking about T0 because of the number of axles that we have. So there are shortcomings, but the manuals, now that we are in the process of updating them, we will try to see how we can capture all that. Sorry about that. Then the question about median barriers. Yes, I know in the past we have been trying to put something that is flexible, that if a car dents that it's not fatal. But notice from the recent past, all the other roads, the crash barriers have been now concrete. One, there is that vandalism. Two, you can imagine those huge trucks veering off to go to the other road. The damage it can do to the oncoming, because one car one vehicle is coming at 100 kph and you're also cruising at 100 kph. If the median there is not proper, you'll be crashing at 200 kph. That will be certainly be fatal if you go to the other side. So the tendency these days is to put a median that is not flexible, that is rigid. What we also do is make sure, because of the maintenance, we are leaving some gaps such that which are movable. Because sometimes maybe the maintenance team is working on one side, you can cross part of the road and have the traffic joining. So even if we are having continuous, like say maximum 100 meters, such that should an accident occur and we need to cross part of the road, we can use the other side of the road. So it's not rigid, it's permanent. We anchor them, there is a foundation there, but the base is just pressing it on concrete, real concrete, so that it doesn't crack. Somebody asked about the hydrological survey we do on bridges. On those 3 bridges across the sea, you don't have to do the normal hydrological survey, but we use the bathymetric survey. We check the highest tide. The highest in the sea, there is the lowest tide and the lowest low, depending on the type of the season. There is the highest and the highest, both daily, monthly, annual, and seasonal. So the tides are the ones we are taking care of. The other volume of water coming from the streams is so small and insignificant compared to the amount of the water which is coming through the tide. So we don't do the other hydrological survey. issue of the subcontracting, yes, the subcontracting is good. You can have many subcontractors, but they should not be under the direct supervision of the consulting or the supervising team. There should be an umbrella contractor for purposes of ensuring their performance guarantees are provided, proper insurances, and that coordination. Otherwise, if you leave it, each one of them to be, even procurement-wise, Kenya cannot go in one project procuring that the contractors. But if you can contract one major contractor who under him as could be having others and he can manage them, that is okay. But they are not procured directly. They are all coming under the main contractor. Yes, yes, cost benefit. Yes, you can check the cost benefit of this project. In fact, it supersedes our expectations at the design stage. So it's good to check. The factors are there. You check with the traffic. You check out the usage of the road. If you take the cost analysis benefit, exceeds. In fact, this is where we beat our financing partners because they tend to rate our projects low. But once they are constructed, the way we are using them, the cost benefits are immense. Thank you.
Thank you so much. We are going to take one more round of questions, and then we will come to a close because I can see time is not really on our side. But before I come back to the plenary, I think we have a question online. So I will pick a question from online, one person to ask from online. Then I'll come back to pick more questions here, and we'll have our presenters to respond to them. You can go online. Say your name and ask the question, please. Yes, the person online. I can see EO. EO, please put on your microphone and speak before we come back to the plenary.
I don't know if I may go or there's somebody else talking.
You can proceed, please.
Alice, please go. I have two questions to Engineer Mutea. One is kindly requesting to briefly repeat on the aspect of VOP setting on the constant A at the point of his presentation. Us on online did not really get that part of presentation. And secondly, is there a specific guideline on setting these rates on VOP? I'm making reference to the diverse rates that are provided by contractors. You may find the contractors tendering in the same year, economic setup. For example, they are sourcing from the same country. And when you see the rates that they are providing, they are greatly varied. So is there a guideline that can be used to either? And is there a way we can try to tame those variations? Thank you.
Please come again on the first
Amandi
question.
can go.
Thank you. My name is Omondi Okoko. I'm an engineer. I had a number of questions, but some have been answered. For example, the crash analysis of the barriers. And so my question would be, noting the project durations, I realized that some projects are tendered and then the commencement is like in 2 years. And in terms of land acquisition, is it possible to have a precondition to commencement so that maybe you have a condition that before issuing the commencement, you shall have maybe implemented RAP to maybe 30% or 50% just to reduce on delays? Two, in the presentation by Engineer Mutea, are there any modifications to materials adopted, ability and green technology in construction? And then in terms of the project payment, I would love to know what the payment currencies were. Was there a payment in different currencies? And if so, what rates were adopted at payment? And how were they able to handle maybe foreign currency fluctuations? Did they fix the rate of the exchange rate in the payment? I think those are my questions. Thank you.
Thank you so much. We'll come back to the plenary now.
Finally,
so
Engineer Brian, you can go.
Thank you, Engineer.
that should be the last.
My name is Engineer Mbima, currently working at Lamu Jara Garissa project. I have 2 sets of questions, one to Engineer Mutea. I wanted to find out, since the project was highly embraced technology to some extent, did they use geogrids or geotextiles, maybe in the slope stabilization or in their earthworks? Because we know geogrids and geotextiles is a current technology, and it offers advantage of soil stabilization. It also offers advantage of or allowing for water to flow at the subsurface. And those are some of the challenges which have been highlighted in the project. So to what extent was this kind of technology embraced? And if not, maybe what were some of the reasons? And my second question goes to Engineer Dorcas with regard to artificial intelligence. It's something which is coming up. And with regards to bridge maintenance systems, you know, reinforced concrete, we have 4 major, defects that are associated with the reinforced concrete with regards to settlement cracks, shear cracks, or even longitudinal cracks at the joints, or even random cracks. So with regards to artificial intelligence, do we have a way in which this system, through machine learning, can classify some of these cracks so that an engineer can be able to know the cause of the crack and also inform proper intervention measures? Thank you.
Thank you so much. Thank you so much.
Back to the
Thank you in studio. We realized that when the questions online were being asked, we were experiencing that landslide habit where at the time when he's about to say the real question, it gets a bit of a disconnection. So I trust that Engineer Mutea, as much as possible, if you captured the question, you can respond to them. We'll come back to take maybe 2 people from the plenary before we come to take the answers, but I'll read comments from online. Someone says, I can confirm the occupational health and safety culture in the project was phenomenal. This is the reason we had minimal incidents. Another comment says, the partnership with Mokifa in mangrove tree planting and tendering is worth noting too. I'll pick a question from him, and then there was a question here, and then we'll come back to respond. Thank you so much. Please say your name and ask the question, and then we'll take one more other question from the plenary, and we'll take the responses.
Hello, my name is Zachary. You are a great LC. My question goes to Engineer Mutea concerning the piles and maybe the piers. We know the effect of water and the sulfates and the concrete. Will you give a recommendation to the authority maybe on how the maintenance will be achieved? Because we don't want this project to deteriorate in the next 30 years. So I want to understand, will you give a recommendation plan on maintenance on the piles along the bridges. Thank you.
Thank you so much. I had seen one hand. Did you have your hand up? Okay, right at the back. At the back, you can give the microphone, then we'll come to take the responses.
Okay, thank you. My name is Kanji Dennis. I had a question for Engineer Ogege, but I think Engineer Mutea could answer for me. So my question was, besides the slope protection works that were done, I wanted to know whether the authority of the consultants or the contractors considered, let's say, other protection measures or intervention measures like soil densification or the use of geogrids, depending on the structure of the soil during the geotechnical investigations. Thank you.
Thank you so much. Thank you for those questions. And now we'll be coming to our presenters to respond to the questions. There are quite a number, and I hope you've noted them down so that you can give us responses. Again, as usual, Dorcas, you'll go first, and then we'll come back to Gina Mutea.
Thank you very much. My question was from Byron, and the question was that we have 4 types of defects that occur on concrete bridges, and mainly we have cracks that are caused by different factors. So do we have a way in which we can have AI classify these cracks based on the cause through machine learning? Yeah, so what I think is that this is possible because already today we have AI models that can be able to detect cracks on bridge surfaces through computer vision. So I think that based on this, we can be able to train our AI models through now machine learning to know based on maybe where the location of the bridge is, of the crack is, or the shape of the crack. We can be able to train our AI models to tell us what is the cause of the crack. I think it's a possibility. Thank you.
Thank you so much, Engineer Mutea.
First of all, sorry, there was a first question which was asked, which I didn't get, but let me answer this one. If I have missed it, somebody can help me back to the question. One of them was on variations of prices, if there are guidelines. Guideline on the variation of price is just that formula. There is no other guideline. You know, variation of price is a measure of, is supposed to safeguard the contractor against the price increase or price increases of construction materials, and particularly because of the inflation. Some of these countries out there, the inflation is not that as high as ours, although ours we say 9.5 sometimes. I don't want to argue with the economists. You'll find like in the last, between January 2023 and December 2023, the price of fuel went up by 100%. Those type of things are not very usual in the other developed countries. So this is our own problem of our own administration, the way we do, because we handle the taxes, we handle few things, and the way managing the tenderers and the rest. So our problem is peculiar. So that's why we are having that. Of course, some other African countries here are worse than us. So there is, apart from that formula, there is no other recourse, but you know very well our contracts, we only give their 10% for variations of price. So now when you start getting 60-70%, then you know it's distorting the contractual arrangement. The employer and price increases by 60% because of variation of price. You know, it has distorted the whole contractual arrangement. So we ourselves, we have to see where is the rain beating us from. And that's why in the last forum, we are trying to identify some of the areas that we have been making mistakes. One of them is that factor A, which has been very high, very low, making the whole project become legitimate for, applicable for variation. when it is only a small element which is increasing. So we are trying to see how best to arrange for that. I know during that seminar, there were some people even who were asking, should we put a timeline so when we should be applying the variation of price? Say that, like for example, it should not be applicable in the first year or so. All those ones, we can discuss them, but the elephant in the room is that we need to see how to tame the variation to be maximum 20%. Beyond 20% is distorting the contractual arrangement. Previously, in the old days, variation of price, we were giving the actual paying contractors the actual difference. That means contractor at the time of tender, you would give the prices of various items, say steel, petrol. You give the quotation from the supplier. During the contract, the operation of the contract, if the prices increase and he is buying 10,000 grams of bitumen, you pay him for the actual price only of bitumen. So the application of the VOP was on the actual elements. Unfortunately, people started fiddling with that system. Some people would exaggerate the receipts, the vouchers, then they show that they have acquired a lot of fuel. So now that's the reason why it was agreed to use the Findic formula, where you are using that formula which I portrayed there. So apart from that, maybe as any client can see how now to best to adjust those factors, but there is no any other method better so far. That is one. Then we go to conditions before commencing of the contract. I know Parliament has been on this, saying that the contract should not be started before we have completed the issues of RAP. That is a good practice if it is possible. But you know the challenges with that. One, it is the same politicians who will come quickly pushing the authorities to start the contracts as early as possible. That is one. Okay, some projects. Other projects, sometimes you find there is no money. Like now, I'll give you an example. For the last 4 years, we have had money for Mombasa Gate Bridge, but we cannot start because we don't have enough money. We don't have money for RAP, which is 20 billion. There was a suggestion that we start the project as we are looking for money. You see that becomes now an option. So sometimes you think that in 4 years we will have obtained money to pay for the lab. But you see other projects are also coming up, going for the same amount. So sometimes it's very difficult. Thirdly, issues of lab take too long. You know, they are to do with the land. And you know, in Kenya, land is an emotive issue. Some cases which were started 10 years ago, they are not over. People are still arguing. The family people are fighting who is the rightful owner. So sometimes it's very difficult. So there is, maybe what we can say is as much as possible, or whatever is within our means, we try to make sure that the RAP is paid. But I can guarantee you there is no project you will start with 100% no encumbrances. It's not possible unless maybe in the sea, where there is no owner of the land. But as long as you are touching Kenyans' land, there will be a fight. Issues of payments, yes, our contractors, package 1 and package 3, we had 2 currencies, Kenya shilling and the dollar. And in the 2, we had a fixed rate for the contract. It is the contract, the rate at the time of tender. That is what you keep. However, if the Kenya shilling, we need to pay the contractor. You see, there are some items which were tendered as dollars, others were tendered as Kenya shilling. If what was tendered in dollar, we don't have the money to pay, and we are paying in Kenya shilling, then with that time we will revert to the current exchange rate. In package 2, we had 3 currencies, with 16% is yen, 64% is dollar, 20% is Kenya shilling. So when, like now, JICA and to pay the Kenya portion was in Kenya shilling, that's why we ended in 20%. JICA converted that into dollars, and we used the contract rate. However, when we come back now to repay, we will revert back to the old exchange rate. So the Kenya government will pay the dollar at the time of tender, which was 2017, which is about 100 shillings. So there is gain and loss. But we are able to stabilize to keeping the currencies in that form. I know one of the challenges that has come to that is the loan was denominated in the yen. Since the financiers to look for dollars to pay the contractor, the conversion rate, because he has to pay him in dollars, will be the current conversion rate. So the loan which was negotiated in 2016, we used the amount of money including the contingency because of that change. Because when the Kenya shilling has been getting devalued, the dollar even underwent more serious devaluation than even the Kenya shilling. 4 years ago, the Kenya shilling was the same. About 100 Japanese yen was 98 Kenya shillings. Today, 100 Japanese yen is 88 or 89 Kenya shilling. So there is those changes that affect the loan. But the contractor is paid in the currencies and the form which he tendered. That is that. The protection works, using geotextiles and the others, yes. We also use that, but you know those ones are mainly in the embankments. What we portrayed there is the slopes in cuts. So that's what the protection with that you can't. It's very difficult to use the geogrids. That's why we were protecting the water contact. That's why we were using those shotcretes. You saw the shotcrete from the valleys. Make sure there is a thin element of concrete such that water does not penetrate to reach the shale. Okay? That is what we are using. And the other areas like where there is that landslide, even the geotextiles will not hold that force. We were using piles. Along there, what we have been using is we have been driving piles to hold back the soil from particularly the airport section. We were piles in various layers. First layer, because you see the slope is about more than 25 meters. At various levels, we would put sheet piles to hold a certain level of the soil and then go another level, and then you can do the rest of the protection. But if you are doing embankment, you can use the geogrids. They are usable, yes. The piles, what you are seeing in the sea, yes, they are steel piles. One of the things, the area that is which is permanently underwater is not going corrosion. The corrosion is mainly within this area of between high and low tides. That's where where the weather is aggressive in corrosion. Beneath there is no corrosion going on. And that our pile at that level, inside there is concrete. Sorry, here we didn't need to, I not time to get you of how that pile is. It's hollow, but that part you are seeing visible, inside is concrete. And the reinforced concrete. And we are put, after what you are seeing, the steel there is only for protection. And we have calculated that steel For it to go, the corrosion to reach the concrete, it would take us 100 years before you reach the concrete inside. Nyari Bridge is now 44 years. It's not yet even half the life of that bridge. So our piles there, in fact, 1 millimeter to reach the concrete there would, the actual period we are seeing, it will be 120 years. But in addition, we put another epoxy, the coating there. That coating itself will last another 25 years. So from here, the maintenance will be on the epoxy of the 25 years. You are still, there is the protection of the steel, which has another 120 years before you reach the concrete, which is the one which is the real support. There at that level, the steel element is only for protection, is not for reinforcement. Where it is, it's supposed to carry the weight is down, further down. You know, those piles, they were ranging from 35 to 47 meters deep. So the depth in down there, because there is no oxygen, it's not corroding. I think I have answered that. Maybe only the first question which I didn't get. Sorry.
Thank you so much, Engineer Mutea. And for some good reason, you took a bit of time to dwell on the price escalation, which is a big topic. Perhaps one time we might consider to come back here. I know there is a committee that had been appointed to delve in the issues of variation of prices, how the indices can be handled, how the formula can be used in different jurisdictions, different financiers, and that will be a very interesting topic. Fundi wangu wa mitambo ananiambia masaa sasa ya mkutano imeisha, na mimi kama MC sina budi kusema tutatamatisha pale. And for us to come to the end of this exercise, I wish to invite Engineer Victoria to come and give us a vote of thanks and bring the meeting to a close so that we can call it a day today. Welcome, Daktari. When I leave here, I'll not come back again. I want to say
And then the session has ended on that note. Thank you very much.